Today we're going to talk about basic safety relays. Now, a little bit before we get started, this is not meant in any way to teach you how to wire a safety relay on your machine. It is more about us understanding safety relays enough that we can troubleshoot them. When you're ready to add a safety system to your machine, then you need to consult someone who is TUV Rhineland certified or go through one of those classes. At our training center, we have a PowerFlex 525 on the technician stations. That is a safe torque off drive. We're going to talk about that probably in the next video. And on the back of them, we have a very basic safety relay, and we have two small safety relays. Here's where it can get really confusing. This is a safety relay. These are actually force guided relays that don't have the tamper-proof set or don't have the overrides on them. We usually call them safety relays too, but when you get them side by side, they can get confusing. But what we want to go through is just how we would wire a basic circuit with the hope of understanding it. Now, if you're just popping into YouTube and seeing this, I really strongly urge you to go see the Why Do We Do Safety video that we did, where we really explained why there are two contacts on our e-stop, why we have two relays, why we need this thing in between. But in this one, we're just going to talk about the basics of the wiring. And we're going to go through the same slides that we actually do in our in-person training class. And yes, I mean, if I don't stress it enough to you, what does it mean to be safe? We spend a lot of time talking about that before we ever hook up the first wire. But in here, what we're going to do is we're going to do the basic wiring of our safety PLC. So we are going to start by wiring S12 on our safety PLC to one of our e-stop contacts and S22 to the other one. Now, one of the hardest things to understand about this relay is I really got confused about what is the front and what is the back, because there are two sets of connectors here. In fact, let me pop that off so you can see a little closer. This back set of connectors, that is the top line of text. The front one is the bottom line of text. And I don't know why I struggled on that, but mainly S12 and S22, they're both on this back connector here. So I'm going to take the S12 wire to the bottom left contact, and we're going to take the S22 to the bottom right contact. Then the other side of those e-stops are going to go to S11 and S21. Now be really careful, because S12 needs to go to S11. S21 needs to end up on S22. If you cross these two wires, you will get a fault on your safety relay. So those are on the front part of the connector, and they are the right-hand one. And we'll take the S11 to the top left one, and S21 to the top right one. And next we're going to wire the power wires. And at first you may be like, well, why did we wire the e-stop before we wired the power wires? But if you actually physically try to wire one of these, you'll understand why. Because S12 and S22 are on the back here, and the A1 and A2 that power them are right in front of them. So after we hook up the A1 and A2 wires, it's really difficult to get to the S12 and S22 wires. So on that top connector, we're going to put wires in the left and second from the left terminals. And A1 is going to be our plus 24 volt, which on our trainer is the left set of terminal blocks. A2 is going to be the minus. That's going to be the right set of terminal blocks. And then let's go ahead and power this up, just so we can see where the indicators are at and kind of walk through how this safety relay works. So we have our power indicator and we have our input indicator. We press the e-stop, it drops out, we pull it out, and it comes back. So that tells us that our circuit from S11 to S12 and S21 to S22 are both good. And now we have a flashing output light. And that means that we are looking for our reset. So notice you have an automatic reset and you have a manual reset. Now, arguably on any monitor machine, this probably should be some type of second action. You shouldn't be using an automatic reset. our manual reset is going to double as our monitoring circuit on our output devices. So we have two relays here. And so here's a really good example. On this Compact Logix PLC, we have an FP+. Now, even though these are 24 volt, they could be doing dangerous things. So we do need to interrupt this power depending on our application. Well, since we have a singular FP+, that means we have a single point of failure on this. So these are the type of cases that you'll usually see two relays. Now, nowhere in there did I say that just because you see a safety relay, you'll see two output relays. That has to do with category numbers, and we're not getting into that in this video. But since we have these two relays here, they have no way of actually self-monitoring themselves. So we're going to need to monitor them and make sure that they de-energize before we do the reset. And to do that, we're going to use the normally closed contacts on this. Now, for simplicity on our trainers, we do have some jumpers already installed, but there is a jumper that will need to be installed between one set of contacts and the other one. And if we look at our wiring diagram, that would be this item right here. Now, after that, we're going to take plus 24 volt into one of the normally closed contact. And then we're going to take out of the other relay's normally closed contact, and we're going to go to whatever our reset button is. And then we're going to go to our S34 terminal, which is that reset. We're going to take a wire from the common of our left relay to the plus 24 volt of our power supply. That was that left terminal. Then we're going to take a wire from the common of the right relay, and that is going to go up to our button. Now notice we have one set of jumpers here. This is because in our training class, these pre-jumpers just save us some time. But for today's exercise, we are going to do it on this isolated contact. So I'm going to go to the top of that one. Then we're going to take a wire from the bottom of that normally open contact. Now we're going to connect it to S34. Again, I really struggle on this front and back, but it's the right front contact is going to be our S34. And now let's power it up and see what that does. So we're going to power up. So we have our input. We press our E-stop. It drops out. Pull it out. And it comes back. All right, we have a flashing output. Now, hopefully, we have plus 24 going through the normally closed of this relay. Then we have the jumper over to the normally closed of this relay. That's going to go up to our blue button that we're going to use for our reset, and that's going to S34. So when I press our blue button or button 4, I guarantee I put this in the wrong spot. I don't know why. For some reason, I have a real mental block on how they have laid out these terminals. But and I did just add these to our trainer. So let's see, is S34 the one back here? There seems to be something backwards between the top and the bottom, but maybe it's just I'm backwards. We'll plug it in. All right, we're powered up and we have an indicator for our inputs. We press our E-stop, it drops out. Pull it back out. We have our output. Now, if we've done everything right, that means we have plus 24 volt going to one of our normally closed contacts on our relay here. And then we're jumping over to the normally closed contact on the other. That is going up to button 4. And then that is going around to S34. And when I press button 4, which will be our reset button, we should get an output on this. Then I heard a click and now we have a solid output. And what that's done is that has closed these contacts right here. So now we have 13 and 14 as one contact and 23 and 24 as another contact. So we can use that to energize our relay. So let's take plus 24 volt from our power supply to 13 and 23. Now notice they're the ones on the back here. So 13 is the left terminal block and 23 is the third from the left. And then let's connect wires to 14, which is the other side of 13's contact, and 24, which is the other side of 23's contact. And 14 is going to be the A1 of our left relay, and 24 is going to be A1 of our right relay. So that is going to put positive power on one side of our relay coils when our safety relay energizes. And so the other side of our relay coil, which is A2, that's going to need to go back to the minus of our power supply. All right, now we'll power that up. And our emergency stop is out right now. So we have an input, we have a flashing output. Now, if we press our blue button, in addition to seeing this output light come on, we're also going to see these relays energize. So press the button. And so that's going to get both of our relays energized. When we press our E-stop, that'll drop both of them out, turns off our output, turns off our input. And that'll get us back flashing. All right, so that gets us through a basic safety circuit wiring. Now, that is not nearly enough for you to go and say, yeah, I learned how to wire an E-stop. You do need to learn about categories and stop types and all those fun things. But we have one other issue that I see a lot of, and that is this PowerFlex 525 drive. It is a safe torque off, and that does mean that you don't need contactors to interrupt them for one. But it does mean there's one item that seems to stump us the first time we ever wire one of these. So click here to learn about your PowerFlex 525.